Before we can carry out any milling operation, we need to consider how we're going to hold the workpiece. In the vast majority of cases for general purpose milling, when you're working with rectangular shaped workpieces, a milling vise is used. The milling vise is different to the bench vise in as much as it is more robust, more accurate, and the faces and base of the vise are machined accurately and hardened and ground so that they're very smooth, They're parallel and the faces are perfectly vertical. The workpiece would be clamped into the vise. Now, as you can see, this vise hasn't been secured onto the table. The vices are secured onto the table using T-bolts. This part of the T-bolt slots into one of the T-slots on the table and then can be fastened down using a washer and a nut. The table alignment must be in line with the vise alignment, which means that we need to have a process to align the vise so that the vise jaws are in line with the axis of the table. In order to align the vise jaws so that they're in line with the table axis, standard procedure is to take a parallel ground bar and to tighten it into the vise. This means that the faces of the parallel bar are exactly in line with the faces of the vise jaws. The next stage is to slightly tighten the two bolts which fix the vise down. And for one of the bolts, tighten it a little further. This means that this bolt has been tightened more than this one. If I then try to move the vise will pivot around this bolt, which is tighter. The method used to align the vise is to use a dial test indicator, which registers the amount of deflection when the plunger moves. It has a magnetic base, and the magnetic base is normally attached to the face of the spindle. So that the plunger can be applied to the flat face of the parallel bar. When the machine table is moved so that the parallel bar touches the plunger of the dial test indicator, it can be seen that the needle will move. Once the dial test indicator has been engaged with the flat face of the parallel bar, the machine table should be moved so that the plunger of the dial test indicator is approximately in line with the nut, which has been tightened fully. The dial on the dial test indicator should then be zeroed by rotating the outside collar. The table should then be moved along so that the plunger is in line approximately with the opposite end of the vise. It should be noted how far the dial has moved, or sorry, the needle of the dial has moved, and also in which direction it has moved. It can be seen that the needle moved anti-clockwise from its original position, which means that by moving the plunger we can see that to get back to zero, this part of the parallel bar would need to be moved towards the dial indicator. The method for moving the vise is by using a mallet, never a hammer, which normally has one copper end and one rawhide end. Neither of these two materials will damage the steel which the vise is made from. The method is to tap the vise slightly on its heel until it's almost round to zero. The vise will be pivoting around the centre of the bolt which has been tightened the most. We can then move the vise back to its starting position. Check the zeroing of the dial and then repeat the process. It can now be seen that the needle has moved very little. It's moved 2 graduations in an anti-clockwise direction. That equates to 2/100ths of a millimetre. So that means that there is 2/100ths of a millimetre misalignment from one side of the vise to the other. That would be acceptable for normal working. 1 full rotation of the dial equals 1 millimetre of deflection. I'm going to tap the vise gently, just a small amount, and then repeat the process one more time. As can be seen this time, the needle has barely moved. So that means that the vise is now aligned with the axis of the table. At that point, both of the bolts can then be fully tightened. Once the bolts are fully tightened, we should perform one last check to ensure that the vise hasn't moved while the bolts have been tightened. The vise is now exactly in line with the axis of the machine table and is ready for use. I'm now going to show how the tool is fixed into the spindle of the machine. The inside of the spindle has a taper similar to a Morse taper on the tailstock of the lathe, however the angle is a little bit steeper. The tools or tool holders have a matching taper which fits into the taper in the spindle. Each tool holder also has two rectangular notches, and these notches are intended to engage with the two square keys on either side of the spindle, like so. To fix the tool in, we need to use a device called a drawbar. A drawbar is basically a bolt, but a very long bolt. It has a screw thread on this end, and it has a hexagon which can be used with a spanner on the opposite end. The thread matches the threaded hole which is in the end of the tool holder, and it can be seen that they can screw together. The drawbar runs right through the hollow centre of the spindle. As can be seen when I withdraw this drawbar. To fit the tool into the spindle, in this particular type of machine, it's necessary to stand on the platform and offer the tool up to the spindle, push it by hand as far as it will go. At that point, start turning the drawbar by hand, which means the drawbar is screwing into the threaded hole on the end of the tool. Once that's tightened finger tight, and then take a spanner which matches the hexagon on the top of the drawbar and tighten the drawbar. The tool is now fixed into the spindle securely. This type of tool is called a face mill. It has 6 cutting edges, and these cutting edges are tungsten carbide indexable inserts. Once the edges are worn, the screws can be taken out, the inserts can be rotated to a fresh edge. Although these inserts are very tough and very hard, which is good for cutting steels, they are also very brittle, so care should be taken not to bump the edges onto anything hard. For this reason, before I fitted the tool, I had it resting on this soft pad so that it wouldn't damage the cutting edges. The tool should be offered up to the spindle and placed fully into the spindle. It needs to be held there